Hey there, welcome back to the channel. So in this video, we are going to focus on performance. So there are some performance changes that we need to do. In previous video, we looked at what were our bottlenecks, which was front, and I think I've realized like what I need to do. It's something similar to what Ricktop and the implementation that we saw in Zig. They basically did one thing, which is they had a cache variable. And I think it's really important for front. So now let me just show you what I'm doing. Uh, just a minute. So first of all, the most basic optimization that we see over here is that do you see it? So we're taking next, right? But we are not even using it. Bro. We are just doing like tail fetch add one, like dog. We can just do this and this would still work. So that was the most basic implementation. The next thing that we look that I understand is that what's it? Yeah, okay. Uh, for now we can just change the names instead of like having next. We can just have this, and we'll just add head with us and capacity. This one. This feels better. Also, since we are doing fetch add, we don't need to fetch the value. We already have the value. So we can just directly do a store operation, which will be h plus 1. Right? Cool. And this is to memory already is. Similar case. So you will be seeing like y is like, oh, okay. So let me do one thing. Let me just keep what it was. I think we should do this. Should we yes, fetch add fun edge is no. So we have only changed the name for next. I think so front we also have something to change in front. But let me just show you the speed difference that that the speed, the performance difference when we are doing a read modify write operation. It's, and when we are doing a directly read and modify, read and write operation. So let me show you. Because fetch add has to do one thing, which is it needs to perform read, modify, and write all of these three operations atomically. So it has to ensure that, and that takes a tool. So let me just show you. What I'll do is that I will have uh, okay, so I'll just copy this, right? I'll create another header which is temp q.h. I'll paste this over here and I'll do what was it? Basic, just the load operation, h and capacity minus one. But this doesn't really matter. So okay, let's just not do it, right? So I'll just do a store h plus one over here. Similar thing with tail. So tail, I'll just do size t is equal to tail dot load. We can just load the values. Okay. Now you might be wondering, like, why am I directly using relax and adjusted memory as a what do you say? Uh, as a memory order, right? So I'll get to that um, because I have found something cool that I totally forgot. So t plus one. Yeah. Cool. Uh, I don't think there is much to this. I remember this. Yeah, cool. So let's keep the same thing. Let's change the name to 10 Q and the constructor 10 Q. Cool. We'll get into the benchmark. them and will copy most of this and paste this directly over here. And just change the name. Okay. Okay. I think this should do it. So if I don't make run, this should show me something. So this is SPCQ, which is at 17,200 operations, BFQ, which is at 12,000, that is crazy. And look at this temp queue at a what? 1 lakh. No, 93,000. Look at this again. 17,000 operations per millisecond. Oh my god, 105,000. Okay, so we have used slightly misleading memory ordering. Let's try to go with the correct memory order. So let me get back to what I was talking about the memory order. So you know how we have okay. So what should I explain first? The thing is that I don't plan what I'm going to see in the videos, so I can't necessarily like say, okay, you know what I need to do? I need to reduce my fan speed because I think it's creating like disturbances. Should I do it though? So yeah. Mm, no, it's too humid over here. But so okay. Let's get back to it. So I'm like just thinking like what should I cover next? Uh, what should I do? What should I do? Okay. So let's get to the basic thing. So okay. What operations? So okay. So we have two variables, right? Tail and head, right? Head is where we push into, and tail is where we pop from, right? Cool. So you can basically say that the producer will most often use head, and the consumer will most often use tail, right? Cool. But one thing is that, like, if you just look into it, so if I do head, okay, there's a head dot load, there's a head dot store, so I see a head dot store, head dot load, head dot load, head dot load, head dot load. Whoa, the only person doing head dot store is a push operation, which is our producer. So producer is doing the push operation, and no one else is doing that. Right? Cool. So what you can say is that head is basically owned by the producer, right? Cool. Uh, well, is tail owned by the consumer? No. Just a minute. Well, it basically is, tail doesn't go through any store apart from sorry, yeah, apart from top, right? Cool. And when we get to size tail, sorry, in the front operation, you can see head and tail both, right? In any other operation you go, there is not head and tail at the same place, like okay, apart from these size, like non-important functions, like um, we have failed over here. Oh, yeah, cool, cool, cool. So what can we say is that tail is being modified. Sorry, head. No, I forgot. I forgot my stream of thoughts. Where was I? So, where was I? What was I explaining right now? I talked about like head and tail. Yeah, yeah, yeah. Okay, good. So I talked about like producer and consumers and who owns it, right? Cool. Now from this optimization, okay, I'll get to another optimization so that will like correctly explain what I'm thinking right now. So in the front, like front takes a lot of time for us, and that is obvious because we are doing two load operations and they are waiting indefinitely for the value to return, right? Cool. But we saw something like cache. So what is cash. So if you look at this, what this check is basically doing is that it's checking like if it is equal to return null pointer. What does it mean? T front asks for what is the topmost element that I can pop, which is like which is like the element at tail, right? So it doesn't care about the head. The only time it cares about head is that bro, like like front operation does not care what head is until and unless it's similar to T, which is basically like empty, right? So what this is doing is that we don't care about head, right? We care about head when T is equal to head, right? So what we can do over here is that we can create a size T head cache that will create a um, local cache for the consumer, right? So front is a consumer operation, right? So we'll create a head cache for the consumer. As I said, head is only controlled by producer, as we saw over here, right? Head is only stored. So we'll create a local cache for consumer of head, which won't necessarily update every single time. So it will update at a specific time, which is so go over here. I'll do a tail load. Tail load is obvious. We need to do that, but I will avoid head dot load. Well, but we need to get the updated value, right? So what I'll do is that I'll check. So we can add the check like if t is equal to head cache, right? So what this means is that I have a local head cache. If it is equal to the tail, that means like, oh, that means there can be no elements, which is might be empty. Well, that is very bad. Let me load up the latest value from head.load, right? Let me load the latest value that I have, then I'll check. So size head, I'll load the latest value, and I'll do uh, another if condition. Go. If tail is equal to head cache, so tail is equal to head cache, which is it's the same thing. If it is, we load the newmost value into head into H, and then we return this is school, and if it is still equal, we return null pointer. So what this did was we create. Is this correct? This should be correct. Like return. So the basically flow goes like we get the tail value, we get the head value, we compare if it is equal to file cache. If it's not, that means there's still something. There's the head cache is still higher than T, which we don't care about. So it will remain head cache. Is that what you want to say? Then head cache should be modified. Why am I doing this? So basically two checks. I did not think of like it like this. Like this. We have T. It is equal to head cache. We modify the head cache. We get the new value. And if then again it's equal, then we'll return null pointer. Is that what I thought? Well, maybe that's what I thought. Let's do the operation again. So we have the changes. So make one 13,000, 12,000, 95,000, 70,000, million, 12,000, million, and 99,000. That's cool. Now I'll increase that further because since we are loading head cache, oh, since we are loading head cache along with T, what we can do is we can make it so that head cache is beside tail. So this should increase speed slightly, not much. Make lean head and make run. Run. 30,000 lane, 70,000, 70, 10,000, okay. 12,000 lane, more than, yup, look at that speed. Look at that speed. Damn, that is the speed. 280, oof, that's fast. 18,000, cool. 281. Well, the thing is that I'm actually, like, it's a sus behavior, suddenly, that suddenly gain so much performance, but it's fine. That's fine. Uh, this is okay. I know that if it's still again equal to this, then return the function. Yep. I can just like return t is equal to head cache. If this is true, then null pointer. If it's not, then leave q t boom 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 boom. Okay. About that, right? Recording. Audible. 7 minutes in, and we have increased performance by a lot. So what we did over here is that we created a local head cache uh, for the for the consumer to look at. We can do similar changes to all of these functions that are doing like size checks. Well, we can't necessarily do anything to size checks. Also, we need to make the memory ordering correct, right? We can't just put relax at every single place, right? So the tail dot load, well, who is going to modify the tail? Pop, right? Pop. So we need to have so the tail is consumer and front is also consumer, so it can be relaxed. That's fine. This head needs to be acquired because this is like inter-core. So the code that is running front. So if you look at this, yeah. So the code that is running the front, which is here, is our. Yep. So this is our producer and this is the consumer. So front is accessed by the consumer and head is accessed by the producer. And what we can say from this is that head head is on the producer branch, so it needs to be uh, not producer branch. Head is on producer thread and front is on consumer thread. So inter-thread communication and this needs to have a synchronizes with relationship. Hence we have acquire over here. Since tail is already present in the same core, we can have relaxed because like just take the local value. It is already the most latest one. In the case of pop, I don't think store. So who's even going to use store from the consumer side? No one is going to use the tail on the consumer side, right? We can make this relaxed too. Okay, let's see. Why not? Oh, let's put the same thing again. We can have this thing. Like, this should go above 300,000, right? So 17,000 lane, 12,000 lane. Okay, it did not. I think in the next, okay, it will do it right now. So 17,000, 18,000. Come on. Okay, 13,000, 13,000. Lane, absolutely. 272. Okay, GG. Oh, why did I run it again? Sorry. So we made some changes in uh, head cache. So like we made the changes in what we have with us slightly. Yeah. So we also looked at why we shouldn't be using read modify write directly. Instead, we should be pressing um, read and then write operations. The next thing that we need to improve is this size. Look at this video score. Okay, who is calling size? Who are the guys here? Like below the should, since we don't necessarily know who they are, we need to acquire it. Yeah, sorry, we need to do it. In the case of empty, well, also, okay, now that we are, now that we know that this is, we need to have this with us. Sorry, boys. Acquire. If it's, we have to check if it is empty, it's the same thing. We need to acquire. Yeah, we can't necessarily let different values get to us. We can add head cache like optimization that we know, but again, that's fine. Yeah. So this is the optimization that definitely I did not come up with. I saw the code and guys, this was a great optimization. 16,000. I think it will cost 300,000. Okay, okay, okay. It's still good enough. Like if I do both record on this, let's see, we need to debug. Okay, I need to change this, right? So I have to make changes from 10K to this. So I'll just go to just go into PHP, boom. And we'll skip to we'll look at how many changes that we did. Okay, I need to seriously need to change the name. If this, okay. So let's change the name first. PFQ and yeah, BF. So we have changed in the push, then we have changed the pop, and then we have massive change in the front, and then some slight changes in the field. And we shouldn't have removed the plus against our spaces, right? Is that what the warning is about? Seriously, I'm just going to remove this. Make do this, okay, and add an to let's put the benchmark.cpp. So it includes this and it's this. Okay. So get restore benchmark.cpp and which direction we're putting. Yeah. And the only get diff that we see is for bfq.h. So that's a good change. And add this, right? So what did we comment? What changes did we do? Create cache of head for the consumer. Create cache of head for the consumer. Right. And git push. It goes. Yep, cool. GG's. I don't think I have any more optimizations left. I think we have done it. So let's test it on the arm. Okay. So we'll test this on arm. So what does it look like? So CD goes in the fast queue, CD queue, yes, yes, select it, okay, and, and, okay, fine. I just do, let us present a bit more, just move it to this PHP.h, boom, boom, clean, and command. Let's look at this. 30,000 operations, 18,118. Okay, it's closed. Okay, it's seriously closed. Okay, I need to change something. Okay, GG's. So we are seeing a consistent 118 and 115. Okay, so something's ever so slightly needs to change, right? Let's look at the number of cycles that both of these codes take, right? So we have Victor with us. If we run 16,000, that's lane. 172,000, that's GG's. This is 15 GG's. So if I run perf stat on Bricktop, I think it doesn't work. Yeah. What if I do perf stat and then Bricktop? Yes, listen. What was the thing that we had to do into the number of cycles? Uh, get number of CPU cycles in perf. Content events during processor execution perf stat. That's exactly what is not working. Stat when the cursor is command the cursor will be events within the user space. Okay. So I need to access points. So sudo perf stat the Victor and the fact strange. If I do perf stat ls, it's the same thing. As this. To change the CPU wide event content past the dash a. Yeah. Well, the thing is that perf stat isn't itself working, so perf stat not working. Yeah. Especially when it does not work with the events. Perf stat dash a, no supported events found. Okay, this user is seeing something similar. So let's look at that. The perf command using the start option is to work with along Fedora, but since some weeks ago the fields the this command used is just an example where actual executable doesn't matter. You could replace the change behavior for both AWS, AWS 43 and return either in the background as a root, not separately this. Once for helps. Maybe a norm issue rather than a general Fedora issue, efficiently represent a I'm having the same problem for now upgrade up to 6.7 17.1 solve the issue. Okay, So downgrading works. Cool. Do both of you see the problem suggest report as a bug as it can be investigated by the data, but for sure we are not more. This will be the same result actually of 6.19 is very rough, but enough 6.17.1. So okay, so my perf version is 6.19. Then they are asking that I should switch to 6.0. Okay, it's working. I'm under it's as a game accelerator. I said accelerator. It's not accelerator. Okay. Mod on my development versions of that works. So version is dash VLS it works. Well, this works. Okay. Okie dokie. Okay. So let's downgrade the perf version. So we installed perf with sudo, well, how to see Pacman list. So install perf on Arch. I think it comes with Linux headers or something. Linux headers, Linux tools, Pacman list. So I'll do Pacman. Database files, queries, sync, dictate, upgrade. Okay. Files, database, so Pacman dash s is for C. Okay. So I'll try sudo Pacman dash s. Does not exist. Use F1 to download. Okay. Dash s perf. List of Pacman repos. Pacman tips and tricks. Pacman cheat sheet. Install list of packages with projects. And the preparation is start with actually some packages. List of Pacman packages. How to list user install packages using Pacman. Opening the local database. Okay, I'm done. So Pacman dash 2. Okay, cool. So let's find perf PERF. Okay. So I need to downgrade this to 6.17. Install Pacman specific package version version. 6.7 is equal to version. Okay. How to downgrade Pacman package. Arch wiki. Before downloading a single video package, consider why you wish to do so. It is due to a report on the multi-party guideline that is searched by archlinks, the tracking system task, and there is none have new task. Please go to the correct box or at least warn the users of possible issues. So, using department cache, if a package was installed at an earlier stage, the department cache was not cleaned, install an earlier version folder of this, downgrading the kernel, delete the package or emission below. Okay, so this is changed downgrade the kernel. Is the exception of this and used to install previous version. Downgrade to previous version of the package, example last version of Python, I will look at this one. You can use it this, it is to all better than 20% downgrade. File package you find the slash packages, the package for installation, for example this, letting package fetch it will automatically download this, define this, and we will download and install package manually using the foundation. Download and install package manually using this. See also download the packages of Team Tester Adult and Power now. Okay, I'm done. No, like this is not something that I need to waste my time on. By the way, I don't think I'm having in my cache. Yup, as expected, only 6.96%. What is this? Damn. Huh? If you see something like this, install it. Method 2, use Archwiki, go to this, download the exact version. Okay, let's try this one. Uh, Let's try this method. So I'm on 6.17, more specifically 6.17 half. So I have to only get the ZST, right? Now the exact version we want. As mentioned earlier, downgrade. That's optional. Downgrade the kernel, asking Sata is the snapshot from just to install this method version of the services provided. Downgrade to a previous version, something password just broken. Yeah, get that. Just use this as okay, fine. I'm going to use this. So 6.17.2. I have this one, so I'll get this. Conference. I to use W. So again, the this 6.17.2. Copy. So 16.7, 16.722. And I'm going to go to I will duplicate this. It's installed. Not installed, but installed already. So out. Okay. And then I go to Pacman dash U. What is the command? So Pacman U. Okay. So Pacman dash U is for Pacman dash U. Dash U is for upgrade. Okay. So Pacman U. Okay. What is it? It was in good. It's this should work. Okay. Cannot open state object and I did with Python 3.13. So this cannot open shared object live. This is fine. What happened? We downloaded 6.7 was built against Python 3.13, but the system no longer has that library. Perfect with this. Install the old Python quick had check if it's cached 3.13. Most likely I don't have 3.13. Yeah, it's 3.14. Uh, we are trying to keep it simple. But Python package star point 13 is fine. Copy the W get this. I think this might take some time. Okay, we're going to take some time. Um, I was doing all of this just run perf, right? Yes. Just hush. Cool. Okay, so there are some performance optimizations that we done. This is cool. 9,000, 10,000, 120. Cool. But the only thing stopping this is Yeah. So capacity is something that to be different. This is, oh yeah, we need to check the CPU cycles. Yeah. And then storage plus one. Mhm. We, we should be doing this. Yeah, because then we are storing the wrapped value. That is dumb. That is so dumb. And also, and this is fine. This wouldn't increase the performance at all. And stuff. So, so Python dash upgrade. The Python crazy thing that we have with us. Downgrading is done. And now our perf should just work. Just work. Yeah, let's go. So perf works. And if I do CBFQ, if I do perf stack these work. And it's going to work. It's going to work. Okay, that's good. Hey, so this is the cycles. Okay, let's try for BFQ. Hey, okay. So context switches. There were no context switches. There were no migrations similar to this one. Task block use CPU utilized was similar, although this is slightly lower. What is this number? I don't know. Good ask. Page faults. Page faults were very less in case of Victor. Okay, page fault is okay. Fine. It's, yeah, definitely it's damaging. So instructions were 24 million instruction, right? This is million, right? 783,000, 24 million. But this is a no wait, it's tres comas. So it's a billion. This is a billion. Yeah. It's 24 billion. 24 billion instructions. And this is 22 billion instructions, which is cool. That's slightly lower. That's cool. Cycles. Cycles are a lot higher in case of laptop. 18,000 it is. And this is like 9 billion. That's good. Branches, 373. So branches, M per second. What is insertion? What is this? Instruction per cycle. 1.137. 2.38. That is efficient. And then the branch misses 0.53% of all branches, 0.65%. Branch misses were slightly higher. So maybe we can like point our queue towards like okay. So how to hint CPU hint CPU branch and CPU. I'm not a very like I'm not known for using Google correctly. Okay. So this is the make general open to any platform language. There are no case about R64, C++, When coding an unavoidable branch in the program flow dependent on IO state, compiler cannot predict. And I know that one state is much more likely than another. How do I indicate that to the compiler? Is this better? If to get this, then this. Performance critical will prefer cache from this branch if the communication protocol needs to move likely or critical value high or false low. Yes, in C or C++, it's possible, but usually not recommended to use a likely macro. Or C++ will do likely to help the compiler make better ASM. That's better for influence and trace transformation. If not in ASM, lay out your code to minimize taken branches for your common case hotspot. For most ISAs, there's only in asynchronous basically middle branches that not some exceptions. This state key code is cheaper than taken, so hinting higher numbers can be output in the password functions. Uh, why don't people just get to the point? Maybe I'm a dumb guy, right? Maybe I'm a beginner, but I don't have attention. Like my generation is really effed, right? Like we don't have great attention spans. Branch prediction, hence CPU branch prediction. The definitive guide for high performance C++. So let's read this. Not even really this is C++. How do we use it? Get to the point. So there's a likely keyword, and the condition is true 99% of the time. This likely macro or C++20's likely attribute tells the compiler which path is the hot path, helping the compiler optimize the layout to make the fast path default branch. Avoid data level branches when possible. Okay, unpredictable. If orders are unsorted, use this instead. Branch this behavior. Sometimes you going to make branches vulnerable that will go to five conditionals. Conditional see more complex instances. Okay, maybe let's just try it. Maybe let them increase something. So branch prediction happens when there are if conditions, right? So if conditions currently are present in try and place and over here. Maybe in the front we can optimize some stuff. So what we're saying is that if t reaches head cache, which means that they are equal, then we'll load the most updated value of the load, the most updated value of the load. Right? So maybe I want to like get the code, like how does it look like? So perf not that, but perf record we need to debug first. Um, record debug BFK before that one as well. Perf record debug BFQ. Okay, and then perf then perf report. So we have front taking this amount of time. Okay, and take this. And this is the thing that's taking the most amount of time. So this is this is heading to logical. Yes. So we have front and accept. tail.load, normally order, blah 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 blah. Cool GG's, simple manual. Item equal, remove this, we compare it, add cache, dot load this, then this, okay, it's taking some time. G this, return the load, and then return this again. Yeah. So maybe I can optimize something that's visible to you, right? So what I'm doing right now is I'm taking the tail load. T is if it is equal to head cache, maybe I can remove the non operations. Right, right. So I have this, I do this, I do this, this is equal, this, that is not equal, then T and capacity minus 1. Let's try that. So make clean, we try 20,000, 115, 120. A difference of 5 nanoseconds, which was earlier, look, it's 4 nanoseconds now. Like we have mostly maxed out on like memory orderings and stuff, right? So I dot store memory ordering is necessary over here. For which we can do this instead. If when we need it, capacity minus one. Yeah, wait, who left this? Yep. Five nanosecond difference. 116 and 120. Okay, 4 nanosecond difference. I think it's still the same. 119, 120. Yep. 5 nanosecond difference. Something is causing 5 nanosecond difference. 5 nanosecond difference is can be because of a single cache miss. What is it something that I'm missing? Maybe something that I can optimize, right? So tail.load, maybe order relaxed, and then store tail plus one. So this is pretty cool, and this is pretty cool. Maybe we can optimize like what push does, right? So we get a value of t, and we just move it into it, move that stuff into it. So move t, we get that, and like this. Okay, so that's okay. Let's look at Richtop's implementation of like how do they deal with front. So I think front is a bottleneck. We need to find some ways to make it better. But here, I think this check is really necessary. It's not that we can avoid it, but maybe we can see like what different is it? Like what is the simple difference that they are doing that we aren't. So let's directly jump to the front code. So we have front. If read index is equal to write index cache, write index is supposed to be head, then we get this. If read index plus do nothing. And if write index cache is equal to read index again, which is the check inside it. Okay, so they're basically doing this. So if t is equal to read cache again, so it's the same thing. So read index, write index cache, write index cache and read index is the same thing. Why are you changing it? No. So return the pointer, and here they are just directly saying with dt is dt is this. Let's look at the assembly code for this. So godbolt.org. Don't die on me, brother. This is taking a lot of time. Where's my phone? I forgot. So just give me a minute. 1 or 2 minutes in, and it's going good. Back and again. Uh, why is it taking so much time? Board. Because get the hell out of here. Yeah, basically doesn't know anything about that thing, right? So what we can do is, yeah, Apache Fit. So it needs something outside, so size pointer, and then we can have an individual pointer front, and then this and this. It will also probably need each other. That will just right, shift up. Yep. So size T, head, cache, it just doesn't work. It's just some directly. And we don't size it doesn't. What? Huh? Size to get cash. Need to counter. So, yeah, you have to compile that. Size to have not dependent in the scope. X6. No secondary display. 968 lines filter. Okay, how about we remove some useless stuff that we don't need to write. So let's get rid of this stuff that we don't need. So we should know compile CDP code to send to GCC. I'm a dumb guy. Okay, GCC, this. Okay, this was actually. What was the change that I did? This. Okay, this is so, the change that we need to do, what was it I forgot? Yeah, G++. So G++ dash dash S. Yeah, this is not what I asked for. That's cool. That's cool. Why does it do crash in one case then? We can okay, let's try this. So I'm going to give to.h. I will do a string s is equal to hello about this. If we run the same thing again, string is not a member of string. Yeah, I will stop on it. Here I'll search for hello. Hello. Yep, we found it. But it's present somewhere in the trenches. I don't even know what this is. CDP images, yeah, double full. Yeah, yeah, yeah. It did not help. Automate readable assembly code. Well, that's what I want. Should I mention that I'm going to the .s extension we started? This again, I'll put something else. But definitely not. Wait, is it because I'm using? Oh no, that's not it. Yeah, maybe it's because like okay, let's give it a try again. So we not really good. Let's do that benchmark. Yeah. So we have benchmark.list with us. Yeah, this is what I want. Let's go. Okay, so so this is not something optimized. I just want to see like how many instruction this is taking. Yes. Uh, I can't. I seriously can't even tell like what's happening. Like the acquire, where did acquire come from? So if I have this in here, I have acquire in the database. How to get just this specific code to compile? So maybe we can do something. Maybe use new.cdb. That's the only choice that I have right now. So I'll just use include. So here I have this. I'll just run the and then .cdb. I'll do and then I'll go to the attach. I'll take all of this. main.cp, paste. Maybe we don't need capacity inside this. We'll do we need BF22, we need head to have cache to so let's try this. G++ dash s main.s. It's this because nothing happened. Main.cp. Maybe we should call this if is initialize this with a basic running capacity. So this should do something. Something like direction. It's not look like that. Sure. Yeah, I need to do all of this code. Cross into other direction. We need to the matching functions all for the cross out of the line. Ask it. Ask it. Okay, a lot of things that we have with us. Apparently, we don't see any hello with us. Oh my god. This is such a thing. Okay. I need to find something like some way to get this, that make this easier. This is horrible. I don't even get like what is it? So we are doing this for me. Right? I think most of it is because of this. This is horrible. Because it's because of this. So if I call front like that, I should run. Like the instructions should be loaded. So keyboard done. So I'll do string s, which is start, right? Maybe initialized everything, so I'll have no problem with this. And then I'll go to right? So this should work. Maybe I should see something. Okay. Let's see. The expected this and pointer, then the pointer, and does not understand why this is too straight. Good. Okay. So I need to look for start. So I have start with me, I have end with me, and I'm doomed. What the? Oof. So where is hello? Hello. Hmm. Oh, let's keep looking. Maybe I will find something. I just don't get like what this N51 is. Like, does this translate to the real code, like line 51, or like what is it? Okay, you know what? Let's try. Um, okay, why not? Why don't I just run like off record, right? So let me just clear some stuff. So I'll clean this. I'll clean this. I'll clean this. This one. This. 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 And this. Just in was removed. And this, that. This, that, that. Let's move this to so, and relaxed. Removed it. This and this. Okay. Yep. And here we do the same. Okay. So now if I do both make debug, so if I do make debug right now, I'll get the front where we are doing if. So, so now we are doing like if for this is horrible too. And then there's another one, which is this one, where we compare this, we load this, and we just compare this again. So we have cache, return null pointer, and let's return this, which will be faster. With the so make debug clean of record debug pfq. So now, if I'm looking correctly, I can see if conditions. So head cache dot local. No, no. So the start happens from the with this state of load, which is obvious. This is all the memory ordering code. So it's fine. I'll see a if condition now. So yeah, this is it. So how many instructions are these? So one, two, three. Okay, let's explore this. So, okay, so that's done. Maybe we three, eight. So so this is the first one, I guess. So if t is equal to the cache, if there's only one, hmm, huh? And this one. So what this does is I have enter if head cache, move the value from RBP, RAX to RBP, and then move RAX to 0 to 8. I need to understand what this is. So shut integrity. And so then show what it is. Yep. Base pointer is just an RBP to create the stack frames. Move this data value into the stack at offset 0x38 from REP into RAX. At offset of this is usually a local variable or safe pointer. This should go 8 bytes ahead and load that value back into RAX. First you load a pointer from the stack and then you dereference it with an offset of 8 bytes. I don't get the minus 0x38 and 0x8. Please explain. Think of these as offset distances in bytes. So 0x38 is an hexadecimal function system decimal. This means go backwards down the stack from this is typically where the local variable is stored in the stack frame. Okay, so there is a local variable in the stack frame, which most likely will be head cache, right? Head cache is most likely what we are asking for. So move, wait, load the value from the stack at offset this from RBP into REX. Wait, this is move this into this, right? We move the right stuff into the left stuff. So there's some syntax for confusing. It will do the orders. Move source destination, so your instruction base means copy from memory into register, write it down, use according to the Intel, but not here. AT&T syntax, what we're seeing, move source destination. Wait, oh my god, how did you find that it's AT&T syntax? Of your use in the instruction before percentage before registers, always prefixes register with percentage. Intel syntax will be this. Yup, it's more cleaner. Ah, offset, it uses offset. Yup, okay, fine. So we move that into RAX and then we will It's 18 decimal. Positive offset means to move forward. This usually means skip the first 8 bytes means the first struct field or pointer access the next field. Okay, access the next field. Hmm. What might this be talking about? Okay, whatever, fine. Then we do this, RAX, then we compare RAX with 18 offset of RBP, which is GNE 144, head crash dot load. And then this and that, this and that. What the school is doing, high level this, yep, I get it. First comparison, so load this, load head cache, compare with T, if not, equal jump. Jump to jump to 144 means yes, if not equal, skip update, if equal, continue. Update head cache load, yep. So this is updation, which is over here. If it is equal, jump to 144. So what is 144? Is it code of the instruction or just non-number? So I have 144 over here. Yeah, okay. Okay, I sort of understand some stuff. Yeah. I'm so sorry, I'm not familiar. I have a bad habit of not taking my posture seriously. So, so what this does is that it compares, not this way, this way. So it compares if it is equal. So JNE is jump if not equal. Oh, okay. So jump if not equal. Location is the function to jump to. If it is not equal to, then jump to that line. Okay. So if it is equal, then do this. It cannot load. Move this, move RBP 38 head cache, which is head cache, into RAX, add 0x40, whatever that is. What is that? X2 0x4. What is 4? It 4 is 4, right? X. Yeah, it's 4. Why did we add 4 to that? Add 4 to RAX, move RAX to RBP 8, and then move A. Let's look at the ChatGPT location of head. Okay. Okay, so it was location of head. This plus 14 is location of head. So this is location of head. Okay. Address of head download 0x2 and we order acquire. Some masking. So this is really order acquire or something. Okay, just give me a minute. So it does this. How does it know like move L? What is move L? This is something that is used to make 4 byte double word values in the memory location of the registers. Okay. Convert to mask and this, whatever, blah, blah, blah. So I'm just going to take this and go to it. So this is total 66 lines, right? There. So the 66 lines, I'm going to add my mark here, you know, just my mark. And then I'm going to make changes into the VFQ. Of record debug queue. Replace or something. And if we go to if, so that is 68 lines. Did we just win? Two extra instructions because of this, and we are going to avoid that. Let's go. GG's, GG's, GG's. Let's look at what the red top guys do. So they've done some of the thing. So that is this is with this. So this is a bad design. Come on, guys. You know we have to improve. You know. So let's just keep this. Let's do it. Most of this stuff. So this gone, this gone, this gone, this gone. Then its status and the diff should show us level two chunks. And this, still no chunk capacity, no. Cool. Boom, 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 boom. Make lean, make run. 20,000 operations and 11,000 slightly. Oh my God. It's still 5 nanoseconds. So we'll make it faster eventually, 4 nanosecond, 5 nanosecond, it's not going to go anywhere. It's not going anywhere. So we are going to, yeah, we will get that, eventually. Where is that 5 nanosecond coming from? I really don't know. Is it because like unnecessary size allocation? Is that it? So right. So maybe we can just do size two. There we go. Maybe this is not going to work. Maybe capacity, capacity. We don't need line as capacity. But we do need it. So we capacity. So size two dot stored plus one. Then we will lose if we two dot goes to million. Two dot store this. Likely inside. How is that like? Super efficient is like things. It seems like an extra couple of 5 decisions of super efficient or an entire. Just put me into the aspect. Okay, so if it's more likely to happen, uh, where to insert likely and see the big difference, likely and likely. So how to use them. I have to add it. Oh, okay. So, so, so this is so when we do this, this is what is likely to happen, right? Unlikely. So you can already start preparing for this. Am I doing it correctly? Okay, it increased because we are forcing certain times down and others down through. It is not like that. Latency increases by 2 milliseconds. So in benchmark.cpp for RTT there is sorry don't lose of quality.one quality.one qt.m+q.m. This movement in place runtime properly fast. So what's happening over here is that we collect lists. Maybe it's because of so what's happening is that most of the time it's calling in place, right? And in place is doing another function call to this. Maybe this is what is taking time. Maybe we should move the logic inside first to employees. How do the Ricktop guys handle it? I think Ricktop guys have done the same thing. So they have most of the logic inside in place and pushes in place B. So it takes a reference, right? B. And then if you search for employees, not trying this, just like this. Yeah. It takes an argument, this, yeah, was. I understand useful logic a little bit. So, so this should increase time somehow, somewhat. So what I'm going to do is call it program. Okay. Maybe use environment references. Push without in place and association with the non-cost and reference type int cannot bind to this. Push is to T object. Passing argument of ambiguity. Audible, audible. So, I think it's that. This is what it's causing. Uh, so if you look at the push for it, so there are two types of push. So what is straightforward? I think straightforward is no convert. Straightforward is the main difference. That is used to be but the following are able to pass against it. But is a the following reference of function algorithm for this depends on whether it's simply unqualified. Forward as n value or as r value depending on it. This is compiled under. Hmm. So this is all the big dip that we have with us, like exercise, treatment, and nutrition. We don't need the size T available, and the rest of the changes. With size T and this is right? Yeah, I don't think it matters that much. So this is the change. Push. I think we are done for the day. So, thanks for watching this video. This is Prashant, and I am an engineer for fun. Bye.